Okay, so here's a very common problem that we see as we're doing lab work with gases, and it involves Dalton's law of partial pressure. So we collect 2,000 milliliters of argon gas, and we collect that over water, and it's at 30 degrees Celsius, and the current pressure of the atmosphere is 750 torr. I want to find the mass of argon that we did collect. Okay, now, we first look at this, we identify what we have. Okay, so I have a volume, that's the first thing, and that's 2 liters, converting it right away to 2 liters. I see the statement of collected over water, which is very important, and so I'll come back to this. I have a temperature of 30 degrees, and that's Celsius. I didn't put the Celsius, but I meant 273 to make it 303 Kelvin, and I have a pressure of 750 torr. Okay, and I'm looking for mass. So, I don't have a second set of conditions, so my basic step process says, well, if it's not multiple conditions, it's only one, and I'm going to use my ideal gas law. Now, above my ideal gas law, there's pressure, but there's an issue. This pressure is in torr, and I can't use it in torr. So that's one issue I have, which would be units. I have volume, the number of moles. This could be useful because moles is equal to grams over molecular mass, and I want grams. So I can actually substitute this in as pressure times volume is equal to grams times molecular mass times the rate constant times the temperature. And I have temperature, which I converted to Kelvin, because this problem needs Kelvin, like all of our gas problems. Okay, now I have this statement. Why is that there? So essentially what I had is I had this tank, and I had water, and then I had this tube, which then I did some type of reaction, and it bubbled gas into the tube. So here's my gas. Unfortunately, this is water. Water will eventually evaporate, and so what happens is there is actually water vapor that got in this gas. So this is not just argon, it's argon plus water. So Dalton says that the total pressure is equal to the pressure of water plus the pressure of argon. I only want argon though. And so the total pressure, which is equal to the atmospheric pressure, is 752 torr. Now, what is the pressure of water? Well, here's the thing. We use this collected over water mechanism so much, we don't need you to calculate it every single time. We essentially give you a table that gives you the numbers for how much water vapor pressure will be. So we're not always doing this calculation, we can just look it up off the table. And so the table is organized by temperature. So at 30 degrees, the vapor pressure of water is equal to 31.82 mmHgs. This is at 30 degrees for water. So I looked that up straight from the table. So mmHgs and torrs are equal to each other. If you remember what our unit said, 1 atmosphere is equal to 760 torr, which equals 760 mmHgs. So this is just 1 to 1. These are essentially then the same units, so let's just put them all into torr. This E, and this is plus the pressure of argon. So the pressure of argon equals, so let's do 752 minus 31.82. The pressure of argon is 720.18 I said torrs. Torrs. Same thing. I now have everything I need to plug in and solve for mass. The pressure is 720.18 torr. That is a problem. I don't want it in torr for PV equals T. I need it in atmospheres. So I need to divide this number by 760 torr, and that is for every 1 ATM. So I did a conversion here. That will get rid of torr and leave me with atmospheres. My volume is 2 liters. I'm looking for mass. My molecular mass, or atomic mass, just look it up. Argon is 40. The rate constant times the temperature. Okay, so the algebra behind this and what we need to see. So I'm going to rewrite it right here so you track. Some people have a problem seeing this. So really what we have is 720 divided by 760. That shortens this up. Times 2. Okay, 40 is divided on this side, so I want to multiply it on this side. And then I want to divide all of this by 0.0821 and by 303. Please be careful if you plug this in the calculator. You either need parentheses or to divide and then divide. Otherwise, your calculator will divide and then multiply. It's a very common mistake that we see. And this is going to equal my mass. So my mass of argon equals 720 divided by 760 times 2 times 40 divided by 0.0821 divided by 303 to get 3.05, it's technically 46 grams of argon. There is my answer. The key thing is I had to realize it was over water, subtract the pressure of water out, and then plug in and solve. Good luck in future problems. Keep an eye out for collected over water. That's all that has to be said, and then you can use your table for it. Good luck.